Welcome to the panel discussion, Deep Learning. Much ado about nothing again. I am David Löh, Editor-in-Chief of Inspect, the leading German magazine for industrial machine vision and optical metrology. The beginning of our today's topic, deep learning, was the discussion about artificial intelligence in the 1980s. The basic idea and wishful thinking were and still are machines train themselves with the help of artificial neural networks and extremely large amounts of data. But the experience in the machine vision industry show it's not that easy. The frustration level among machine vision providers as well as users increases. So is the great big disenchantment also coming now with this third hype of AI? To discuss this topic, I have 5 real true experts here I would like to introduce you now. So first is Dietmar Ley, CEO of Basler, right there in the middle. Jens Hülsmann, he's Senior Research Scientist at Isra Vision. And Dr. Olaf Munkelt, General Manager of MVTech Software. Mark Williamson, Managing Director of Thermal Imaging. And Donato Montanari, Vice President and General Manager of Zebra Technology. So, let's start with the first question. What happened in deep learning in machine vision since the last vision, 2018? Dr. Olaf Munkelt, do you want to start?
Yes, sure. So first of all, we have to say that luckily deep learning has not been affected by Corona. Okay, it was a bad one. I think what we have seen in these 3 years is lots of new applications. So we have seen this technology going into the applications. And we have seen technologies which provided great results, and we have seen approaches which failed. So the learning is, after 3 years, we have now a better understanding what will work with deep learning and what won't work, and what is necessary to make it work.
Does someone want to add something?
I think one of the challenges 3 years ago was that there was the requirements for lots of example images, and there's been a lot of work to reduce the number of example images. So if you have defects in industrial application, it was always challenging to find enough examples of that. So we've seen technology develop to make that easier, and we've seen things like anomaly detection become more into the mainstream, where you can find things that are not normal, which is another good way. So I think we've seen it become easier to deploy with examples in industrial applications.
Okay. Someone else?
Yeah, so the maturity of the methods and the maturity of the products that incorporate deep learning into this vision system, yeah, it drastically increased in the last years. We see a lot more application, and also some of the roadblocks where 3 years ago, I would say there were a lot of people who may not have an intuitive sense of what you are capable to do with this deep learning technologies. And this changed because people get used to it, to use it in daily application, and also to use it for applications where they were like afraid to use it 3 years ago.
So you mentioned applications and products. So in what products of your companies do you find deep learning? Can you explain that?
Yeah, so I think there are 2 main applications and a lot of smaller ones. One, of course, is, and that you see all over the trade show here, is more or less simple application but the actual task is unknown. So you have to train something. What you have on your image is not known before, and then you can train a deep learning network to classify objects, to detect faults, and so on. That's one application that's also very present in ISRA. And on the other side, we have these high-end applications where, like where someone is, for example, in web inspection or surface inspection, where there are classifiers that are built in the last 10 or 20 years, and which now can get enhanced by these deep learning technologies, where you put it as another tool in the box to solve a classification or object detection tasks that was very difficult with classic image processing methods before.
Mr. Montanari, do you want to add something about it?
Yeah, I think that one of the area where deep learning is being very successful compared to traditional machine vision is where it's very hard to really define what a defect is. And these are usually the areas where today human inspectors are doing the inspection, because it's very hard to explain to a machine what a defect is, right? So if you try to look at a human and put it into terms of machine vision, right? We basically have 3 robots, which are both our hands, but most important robot is our neck, because it always go like this, right? And what we're doing by doing all of this is trying to find the best position of lighting and eyes and all of that. And unfortunately, this is very hard to do in reality, right? So we hope that machine vision or deep learning can help us in trying to reduce the number of degree of movements that the humans actually are doing when they do their inspections. And I think that this is a very interesting area of development going forward.
And from the perspective of the user, what is the benefit for the user then? Mr. Williamson, do you want to say something?
For me, the challenge is when you've got a product that is variable. That's been probably the first thing that people started to attack. So obviously, in the wider market with Google, is it a cat, is it a dog? Are you a male or are you a female? These sorts of things, it's very difficult. So what's nice about, for the user, is you can make the decision to create your classifications and then train the system to solve the problem. When that comes to things like fruit, vegetables, in farming is a great application. The product is organic, it's not the same. You can't make a measurement so easily on that product to make a decision. So learning and building up with AI statistical data to define where those points are based on data, large data, helps.
Mr. Lai?
Yeah, I would guess 3 years ago it was quite difficult to find the right tools and components to do deep learning properly and at a reasonable cost point. And we believe that this has greatly changed. There are a couple of development suites available where you can rather easily get to work with deep learning, where you can make experiences and try out your individual application. There are also lots of processors available, meanwhile, that are able to process the large amounts of data that you're creating with that. What also has become much more common is to, let's say, train the networks in the cloud and then to deploy them to an edge device, which is, let's say, more cost efficient and smaller in the end. So I think we have made great strides into making deep learning more usable and more practical over the course of the last 3 years.
Mr. Munke?
Yeah, I think it's important, at least for our customers, which we see, that they get a support of the entire value chain of a deep learning application. So this starts with a labeling tool, with something where you actually can label the data so that the data get ready for being trained, whether in a cloud or on premise.
Yeah.
Let's keep the choice to let's make the customer the choice. So an important thing is that the customer's not really having an idea, should I use now classification, anomaly detection, instance segmentation, semantic segmentation. There are at least half a dozen different algorithms on the table which they can use. And what we have experienced is we have to explain better for what purpose you use what. And you have to actually allow the customer to quickly find out which of these methods work for my application. At the end of the day, the customer will have a solution for the application, and he probably doesn't care so much which technology is being used for the application. So our experience is we have to provide the tool chain for the entire process so that the customer quickly can find out what works and what doesn't work.
Mr. Hülsmann, do you want to add something? Or?
Yeah, so what the other said here is definitely true. Also, we see a lot of progress in the hardware platforms themselves, a lot more embedded devices. For inference of those deep learning systems, it's absolutely no problem to put it in a small box and deploy it directly. Training is a different thing, but as mentioned, these are two separate things. Typically, you don't train as much networks as you use them for inference. And so this can be shipped off to cloud or to add some devices that are shared by a factory. And then you can really leverage the effect of having the training data done once, train the networks and deploy to a lot of devices, and you don't have to adjust them individually because you get the training data set from the whole thing. That's definitely a thing. And also for high-speed applications, you also see that the hardware to do this on a like medium bandwidth camera data stream gets affordable for industrial applications. Because there's always this, if you have just a small image, then you can do a lot of things. But if you have to process a complete camera data stream, especially if you look around here from all these high bandwidth cameras here, you're stuck somewhere with the hardware.
And there's one point to add on this end. If the images are small, you actually can do a lot on a standard CPU as well by using deep learning. But if not, then you have to buy graphics cards. Yeah? And sometimes we got the question, so if I now deploy this, what do I have to do? And then we say, okay, you have to buy yourself NVIDIA graphics card. And what does it cost? Well, currently, depending on how many bitcoins are being found, between 2 and 3K. So before you actually talk about it, the requirements in more detail or the technological approach, how to solve the application, you see a face of the customer and he says, I don't want to pay such an amount of money just in addition. So that because I can't get this back from my customer. Yeah. So the technology, this is the interesting point, is somehow limited because you have to add cost, and nobody wants to add cost. People want to save cost. And on that end, I think it's more important to look into the future and see what's down the road. Down the road, we see that big giants like Intel, they build more MPUs or machine processing units like Apple. They build special cores, neural network cores, in their hardware. So what we hope is actually that this becomes more cost effective for our customers because we can simply utilize that.
I think that's exactly right. So if we go back, what we've always seen is back in the 90s, you had a big PC for an algorithm. Then we started smart cameras when they first came out. Very little processor, very simple applications that didn't always work. As the embedded processors got up, the tools got more advanced. And then people were saying that's going to kill the PC machine vision market. It didn't, because the PCs then could do more complex applications, which now have become more simpler. And we're seeing exactly that with deep learning. At the moment, it's big GPUs, but in the future, it will end up being an embedded module being able to do it. So it's nothing new, it's just the evolution. Moore's law is taking us into that new direction.
Yeah. Okay. Mr. Montanari, do you want to add something? Do you agree?
No, I agree totally with the rest of the panel. This is the typical technological curve, right? You have early adopters, and then you have like more mature adopters, and then the deployment increases because the cost comes down, and so on and so forth. So.
And what are the concrete applications deep learning is most useful, and in which application, second question, it's more or less not useful? Mr. Lai, do you want to add?
We can see benefits in inspecting, let's say, reflective materials. We can see benefits in medical applications where you have vast amounts of data and only small changes in the images. So this is where we have seen, or wood inspection applications, metal processing, paint inspection. Isra would be able to tell more about this. I think these are typical applications where there might be benefits from the software analytics perspective. Yeah.
Yeah, so...
Okay. Okay, now we know. Wait, we will.
I think what they missed at the end of this announcement is there will be free beer at 4 o'clock somewhere over there.
Yeah, I will join. Okay, so yeah, for these applications, that's totally true. So you see applications in, let's say, difficult classification task, where like classical feature-based, feature engineering way of classifying or discriminating between the defects was stuck for some years, and now you can take this next step with the deep learning technologies. In those fields. Yes, exactly. This is the one thing. The other is the simpler applications where you just save the effort of starting a feature engineering to whatever, inspect this bottle. Yeah, how do you do it? How do you measure? Do this, do that? So with this deep learning, you can, to a certain extent, of course, just collect whatever 10,000 bottles. Okay, not okay, and then you can train these networks. Maybe if it's depending on the task, it even today works with a lot less examples. Yeah, so this was always the demon of deep learning, is that you have to collect hundreds of thousands of samples and then it still doesn't work and someone tells you collect more samples. But there is great progress made also in the academic point of view on this, and also in bringing this to the applications.
Yeah. Maybe one comment that I would like to add in terms of applications is that it's part of the blessing and the curse of deep learning is that in our industry, people try to use deep learning when everybody else fails, right? So you've tried your application with traditional machine vision, it doesn't really work perfectly, and you have had that in your factory for a few years, and now you try with deep learning, right? Mm-hmm. Well, unfortunately, it's very likely that it's going to fail with deep learning too. And then, the stigma is, oh, deep learning doesn't work. And I think that we need to be careful with that, because there are some things that you can do with deep learning and some things that you don't, and you don't even want to try to do that with deep learning. Really, just don't. Do yourself a favor. Don't even try. And right now, as always happens with the hype on technological curves, people think that they can do everything with deep learning, right? That oh, give me 5 images and your factory runs perfect. As not the case, right? So I think we need to be very careful about what we want deep learning to be able to do, and also be very careful in setting the expectation that we have for deep learning.
Correctly.
Because at the end, it's just a tool.
Yeah.
Right?
Yeah.
It's like object locate. It's just a very powerful tool, but it's a tool.
I see. Does someone want to add something?
I think that there are even industrial production processes which are tuned, or have been tuned, to comply with Six Sigma. So that means you have a few parts in a million which fail. So you actually have no data which you can use for training. Or you apply a technology which is called anomaly detection, where you just learn from good data and automatically infer what is bad. Yeah. But there is no confidence and no belief and no explanation within this technology which would guide the user in saying, okay, this is really a defect, or this is just an acceptable, deviation. So I think that if we talk about where can you use it, or where can't you use this method, we have to keep in mind what kind of process you are looking at and what kind of data is actually provided.
So what requirements must the user meet to use deep learning? So personal and technical. Mr. Williams, do you want to answer that?
I think knowledge of the person looking to solve the problem is still required, and that's always been the reason why machine vision, you put your vision system onto the production line. Vision's not very good, it's not reliable, it hasn't worked because the sun came out through the skylight in the factory and it stopped working. That still exists. Even with high dynamic range cameras now, they're still not as good as the eye, they're still affected by the environment. You still have to have skill to know how to put the solution together. What are the things to be worried about? What can be controlled? And deep learning isn't a case of just teach, 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 teach. Yes, that's good, that's bad. Put it into the production line and it won't do that. You still need knowledge. So we must get away from this thought to say deep learning is the solution to make everything easy, to solve everything. Machine vision engineers are still going to be needed to architect the overall solution, both in software and in the environment that we have to control.
Mr. Lai?
Yeah, I think you touched a very good point, Mark. So the competence needs to be there. Yeah. The experience needs to be there. Many of our customers, let's say, don't have the competence yet. Yeah. So they are used to PC systems with rule-based algorithms, so they really need to grasp the new technology. Yeah. They also many times don't really have an idea about the bill of material that comes along with it. So that means you also need to verify whether, let's say, the cost of the system that you want to achieve can bear, for example, a GPU processing unit or multiple of them. So that means that setting the right expectations, understanding, let's say, the implications of a deep learning system fully is really very necessary to get to success.
Yeah, absolutely.
Yeah, so this is, as he said, it's a tool. It has its purposes, but it also it has its properties. Yeah, so it comes with, like you said, with additional hardware. But there's also, like in critical applications where everything is like set into stone since several years. Yeah, then you still have this lack of traceability of the results, where you. If someone asks you why exactly to the point did that process to that class, then you can theoretically do that, but at least with the state of the art, you cannot give a good explanation. Yeah? A lot of people are working on that in academia, also in the industry, to give some better explainability to these deep learning systems. But I think that's a few years in the future until you can really use this on a shop floor level.
Mr. Munkel?
Yeah, what we see from our customers is basically two classes. So one class are the people who understand deep learning very well, and they use all the tools which are available on the internet. They compile it, but they have a missing link to the other group. And the other group are the ones which you mentioned, Mark, the guys who know the application, and who probably want to simply have something on hand which they can try out and find whether this works or not, in order to decide, do we want to go down this deep learning path, or do we go down this rule-based path? Yeah. And what we see is that there still is steep learning curve involved on the ones who try to build this from scratch by themselves, because they have to go through all the pain that they probably don't know the exact technology, they probably underestimate the BOM part, whereas the application guys, they are much more practical, they are not so strict, we have to use this in order to prove something. Yeah. So they are more like, we have to get the application going, please.
Yeah. So can there be a deep learning system out of the box someday?
I think we have that with people like Tesla's autopilot, which has had a complete, thousands and hundreds of thousands of hours worth of classifying work going on and all of this to try to get something that's out of the box for a vertical application. In industry, that doesn't exist. we don't have a big enough application to throw that amount of effort into it. That's always going to be the challenge. So yes, people, as Olaf said, people can buy TensorFlow and start to go deep learning for free, okay? That's assuming time is free. The time it takes to come up with the solution and work, it's not viable for most machine vision industrial applications. You need to compress that time. And that's where the value of the tool chains that are being developed in the machine vision industry is to make that, is to make that simpler.
Yeah. So I would agree to that. I think from what we see, the deep learning projects are at the moment really custom, very highly customized projects for individual customers, for individual applications. It's not so much a standard offering yet. Yeah? We expect that with the advent of the big IT companies like Amazon Web Services and others, that there will be tool chains in the future that are quite easy to use and that may work for a couple of standard applications. But this is possibly sometime down the road. At the moment, we are talking about customized individual projects. Yeah?
I guess the expectation to some extent was that if we use deep learning, we have a kind of, a seed which we can reuse in the next application, and then we get a little better. And then there's another application, we can take this little grown seed and put it in there. So it's like you learn from the past applications and the system gets automatically better. So today we see this simply won't work. So what we call scalability of a technology does not really work at this point. I'm very supportive in saying if you start a deep learning project, you start from scratch. The learnings which you have done, they're in your mind. They're in your brain. This is your personal experience because you have some experience with the application and you then go down and implement it. But the technology itself that does not provide this kind of self-learning which would make N+1 application, I would have less development effort compared to application N.
So I would have one additional point. I mean, all that being said, I think the message that should not come across here is that it's awfully difficult and should not be considered. I think there is a big potential behind it. And what we see, especially in the Chinese market, is that there are a lot of people experimenting with it and going through the learning curve right now and are eager to try it out in order to figure out what kind of benefit can it create already right now. So that means let's say from a regional perspective, I think the Europeans here should get into this technology rather sooner than later in order to make sure that they are not left behind. Because there are people and engineers in other territories who are really jumping on this and are learning very quickly how to use it and how to overcome these obstacles that we were mentioning. Yeah?
We have also some startups here in Germany, if I remember correctly.
I think that actually one of the challenges that a lot of organizations face is how do I start?
Yeah.
Right? And going back to the analogy of the autonomous vehicle, the Tesla of the world, the way they started is actually very simple. They drove the car and they took images, right? Yeah. Now, the value of these companies is they have millions and millions of kilometers recorded that they can use to train the network. So to me, really, the first suggestion for any sizable organization who wants to start in deep learning is save images, right? Let's start really with the basic, because as Olaf said, in deep learning you start from zero, and zero means images. Yeah. And also, the myth that you only need 5 images, and it doesn't matter what quality of the images is because the learning is so good and the machine is so smart, that actually turns out to be generally not the case. Mm-hmm. So take good images, take a lot of them, store them, learn how to store them or to organize them. Yeah. And then I think that the other big next step is how to annotate the images. And what we have found out generally is that a lot of organizations that fail in deploying deep learning is because they underestimate how to annotate images. And what we've seen is that the best way to annotate images is actually to be on the factory floor, right? Together with the quality expert who tells, okay, you know, like if I look at this glass, there is a little defect here, and it's just here, and this is why it is a defect. And then you need to be able to transmit that knowledge in the annotation itself. So it's just not enough to say, okay, this is bad. Well, tell me why. Where is the defect? Can you really put a circle around it? And I think that by doing these steps, you can prepare your organization to start looking into deep learning.
Yeah. Let's do the next question. So what are the main difficulties for users to start with it? You already answered it, but does someone want to add something?
I think what Donato just said is a point. Annotation is a critical task for the success of an application. This is also what we have learned while looking at many different applications. And the learning for us was to say, okay, we have to think about how can we help the user to make the annotation in the right way.
Yeah.
So in other ways, in another expression, maybe there's a way to, if the user get a new image, to help him to say, okay, most likely you have to annotate this part of the image. And if you do so, this would add, say, a confidence value to your existing network. So that means if you bring this into a, well, if you want to say so, more a systematic cycle, like a control system, then you probably really get a lot of benefit. This is pretty tough. Yeah. This is not easy. But this is something I think would really bring us forward.
Yeah, but this also happened for the classical machine learning technology. So first there were these particular individual algorithms, and then over the time they added meta structure over this learning system to drive them or to steer them into the correct direction. And I think this is also what will happen here, and also this mixed systems where parts are decided by classical algorithms and parts are decided by deep learning. I think we will see a lot more understanding how to engineer this system, how to put the building blocks together. And connecting to the point from 5 minutes ago, the question is if we will see something like a network that is trained for, let's say, industrial defect inspection tasks, because a lot of big networks that you can use today, they are pre-trained on millions of images from the real world, which have clear differences between such industrial images and images from all over the world, and also different requirements regarding accuracy of classification and all these metrics that are applied there. And the question is if this really gains traction and everybody is doing is if there will be something like a database of all this task where you have really millions of images from all over the world in this, but I cannot really imagine how, but this would really help those networks.
I mean, if you look into the very far future, then we probably have the computer which at the end says 42.
Yeah, okay.
But I don't really believe in that. I'm more a guy like, let's solve a problem. And I don't believe that these networks will really help us if they simply get bigger. They have to get better, not bigger. And the question is, how can we make them better? What we found is we deliver pre-trained networks with our product for various tasks. They serve as a starting point. And then the user can add his own images and then dedicate this to his application. This works fairly well. But again, the point is, if he adds data, how can he be sure that he adds the right data? How can he make sure that the annotation is right? So I think this is not sorted out because there's a lot of, energy in this topic. But let's see.
Yeah, but that's also the thing that we here can do is give the user some good tools to see if the networks learned the right thing. Yeah, so to really trace if those images are classified because of the thing that was annotated, and it doesn't, all these classical techniques, yes, so they have to get some guidance and maybe even some guidelines which training data is missing and so on and so forth.
Yeah, this is what you call building blocks, which I like.
Maybe I try a summary of the difficulties. So to your question, so we mentioned already the integration effort might be higher. So realization effort. So maybe the bill of material gets higher. The architecture needs to be changed in order to bring in new hardware and software tools. Lacking competences, so I need to build up new competences. Data scientists, you mentioned here annotation, which is not, let's say, common in many development departments to have those. And then question is, what do you want to do? Do you want to measure? Then deep learning might not be the right tool at all. So the type of task. And then also, if you are under pressure to get your application validated, then this is also not easy or maybe impossible to do. So to get a validation, because of the black box characteristics of the network, you don't exactly know why the result has been judged this way it was. So also the system may change over time, because when new data is presented to the system, let's say also the classification results change, the network may change. So if you want to freeze your design with a deep learning system, may be also difficult. So that means at this point in time, you need to know what you do. And you need to work together with, let's say, partners from academia or with suppliers, and you need to be patient in order to get it right and to get it to work. Yeah?
Which I think along those lines, one of the bigger problems that I see when people try to use deep learning is they don't seem to have their expectations set at all, right? And usually, again, back to the technology adoption curve, I think you can say that we are now in the hype of deep learning for machine vision. And so you got, this big consulting firms come to say, oh, you're not using deep learning. Something's wrong with you. You have to use deep learning right now. And here is like a 3 years project that is going to do everything in your factory, right? And that's probably not the best approach, right? Because that, it's not going to do everything for your factory. It's like a tool, right? So exactly what do you want to solve in your factory? And start with a small project, right? Start with the 3-month project and learn from that, right? And also, so set your expectations and really try to understand the difference between general deep learning and specialty deep learning, right? So and to translate to our world, you can build a deep learning network today who beats the best chess champion in the world. But that same network cannot drive a car, cannot make a coffee, right? You can build a network which builds the best coffee machines in the world probably today, but it's not the same network that can play chess, right? So the concept of something general that does everything today doesn't apply. So manage your expectations and look at the low-hanging fruit, and as Ola was saying, building from there, right? So
yeah.
So do you think any user need a deep learning expert now? What do you say, Mark?
So the question,
if any user needs to have a deep learning expert,
you need to have the competence.
Any user of the technology, right?
Yeah, you need to know what you are doing, and whether you build this up yourself or whether you partner up, team up with someone else, it's up to you. But you should not have unreasonable expectations. And I think in order to manage the expectations, competence helps a lot.
Yeah, deep learning is like teaching a child.
Yeah.
Would you let your 7-year-old drive a Porsche? Right. So along the same line, I think if you're trying to do a complex project like it is driving a Porsche, you probably don't want a 7-year-old, right? You want an expert driver, and to a certain extent, the same applies. You need to have in-house the knowledge so that you can do the learning and the teaching to the machine correctly.
I think you've got so many factors that can change the data. Just take resolution. If you have a different resolution, is that resolution good enough to find the object? If you go for a massive image, are you going to suddenly be training the texture, not the defect? So you still need to understand contextually the data that you want to put into the network. And I think going a long way in the future, we will end up with different multiple neural networks of different, or deep learning of different layers. This is what we said about driving a car versus making a cup of coffee. The real world, our brain is not, okay, you say it's one neural. We identify what knowledge we want to focus in on. Our eyes focus on something because that's what we know needs to be. So it's a multi-layered thing. And so I think we have a long, long way to go before. Moore's law said, I think, in another 10, 15 years, the processing power of a $1,000 chip is going to be bigger than the human race, or something like that. I think it's every 2 years, it keeps saying, once it was an ant, then it's going up. So at some point in the future, a processor is going to be as good as the human brain. But also, you've got to know how to program that thing. And our brain has learned a neural network to learn. We haven't even got there yet. We're still manually, this is good, this is bad, this is this, this is that. You don't teach a child how to learn. Yeah?
You want?
Yeah, so the regarding the deep learning applications. No, what was the question once again?
The question was if every user needs an expert now.
Okay, this expert question. Yes, this expert. So there are more kinds of experts here. That's what I wanted to say. So one is the expert that can understand what he can expect from the deep learning. Like you said, that's more or less an application expert for machine learning systems or something like this. You don't need to be an expert in whatever internals of what is happening there. You don't need experts for whatever transfer functions in the networks to work on the image processing task itself. That are, I think, two distinct qualifications.
And how does your company support the users in this question?
Well, we provide, say, the entire technologies. We provide pre-trained network. So customers, the idea is to let customers quickly build an application without being a deep learning expert. Without understanding all the layers and which layer is for what kind of transfer functions we have and all that. So we try to hide this. The user can access that, but we try to hide this. And the idea is to quickly have success in the application in order to have a starting point to then go further. Yeah. So this is what we provide. And second, we also recently released an interface where it's the transparent way to support deep learning hardware. So we have seen many different hardware. We will see more hardware on the market, and I think that customers should be flexible in order to use one of them. And this, luckily, if everything goes right, then reduces also the bomb factor on that end.
So 3 things: a hardware starter kit that you just can use and play with, that easily connects. Then an easy-to-use tool set, an easy-to-use tool chain that somehow guides you through the process. And then a field application engineer to help you to get the application solved. These are the 3 ingredients that we use to get it to work. Yeah.
I see. And Mr. Montanari?
Yeah, I think it's I agree. It's very similar to what the colleague said. The big thing for us as a newcomer to the business really is to recognize that deep learning is part of the business. Right? It's to me, it's not just it's something new, or it will it work or will it not work, will it stay or will it not stay. To me, is a tool. And therefore, you need to treat it as such. You need to support it in terms of hardware, software, and application engineering. And you need to understand that it's part of the tools that our customers are going to use. And what we need to do is to steer them towards what tools is most appropriate for the problem they're trying to solve. And sometimes this tool is traditional machine vision, which, by the way, is not perfect, right? So let's not forget that. The reason why we're having the discussion is because traditional machine vision is not perfect. So sometimes the tool is traditional machine vision, sometimes it's metrology, and sometimes it's deep learning. And you just need to use them according to the problem you're trying to solve.
Mr. Williamson?
I think two things really jump out for what we're doing, training and consultancy. Effectively, it's like anything, you need to know you need to know what to use, how to use it. So our Imaging Academy does training. When we have a feasibility on how to best go about this, not solve the problem, that's the customer's goal. We're not trying to build something on a factory, but we sit there in the middle acting as a adding value to help that customer make those decisions if it's using which hardware, which resolution you need, which kind of tools you could be using to solve that problem. Maybe do some initial example ideas to show how it gets there. The key thing is our goal is to teach our customers how to do it themselves. We're not there to do the end solution. Yeah.
So in Israel, we all have this. There are two kinds of applications, how we get it to the user, or we support them. So the one thing is very similar, like if there is a task, we can guide them and help them to solve it with the existing software. But there is a second task where we really step in and do the image processing work with the customer, because it's a common task in some industries, and we can there benefit from experiences all over similar industries, so where we provide solutions then. And maybe a third thing that we didn't discuss here now is that you also have some benefits in image processing algorithms that are internal. So where you can speed up some internal calculations. This is totally invisible to the customers then, but maybe you can even gain with the restructuring of internal image processing some better performance on existing hardware with this.
Yeah, this is what we see as well. The combination of rule-based approach and deep learning gets a success, but we haven't seen an application so far where people simply take image in and result out. So the combination between the rule-based approach and the deep learning approach really builds a successful system. And things like speeding up is a typical thing where you need to code something. So this has nothing to do with the deep learning.
Okay, we have one question from the audience. I just read it and maybe one of you can answer it. Can I store a machine learning model in less than 4 kilobytes?
Could you repeat the question?
Can you store a machine learning model in less than 4 kilobytes?
That's the question, right?
4 kilobytes. Why 4? Why not 5.4.5 or 5.3?
I hope you know. So maybe it's a no?
Typically not. It has to be a very small network.
Yeah.
Okay.
Typically not, yeah.
So maybe the one who answered this question can contact one of these men and ask it again. So we are almost at the end of our discussion, and
let me elaborate, because if we extrapolate for a 4 kilobyte or the 7 kilobyte, I think maybe the question behind the question is, can you deploy this deep learning with limited hardware or very limited hardware? Right? So let's start from the basics. Do you need a GPU to run inference in your lines? And possibly not. I think a fair answer is possibly not. If you can afford it, go for it, right? But if you can't, you can still possibly do it. Do you need a GPU to train the network? Yes.
Okay, thank you.
It depends on the complexity. It's always on the complexity. You can't have how long's a piece of string. Can you do this or can you do that? The biggest thing, what I would say, when I mentioned consultancy, and I think we've also discussed, some people say deep learning, deep learning, deep learning. The first thing we do in our feasibility consultancies is this a deep learning application or not? Some people have got this buzzword that they've been told we need to look at deep learning to solve a problem, when you can solve it with a blob tool.
In which case, for a kilobyte, you're probably enough.
You probably can get it in a kilobyte then.
Okay, so we're running out of time, so just give a short statement. What do you think? Deep learning, much to do about nothing again? What do you say? Mr. Hülsmann, do you want to start?
Yeah, so we think it's clearly a future technology, and it's not a much ado about nothing. It really helps in some practical application to solve certain tasks. On the other hand, I'm quite sure there was a certain hype around it, but now I think it flattens out. People learn to know the in and outs of such systems and can really apply them. And I think now it's really a field where the application will start to grow in a not with a spike, but in a consecutive way to go for more and more applications with more and more affordable hardware, and also with more and more software tools to really help the user to understand what the systems are doing.
Mr. Munkel?
Yeah, I think it's one piece of a cake, so it's one building block, so to speak. It adds a lot of value in many applications, but it doesn't add any value for many other applications. We have to understand the technology better. We're on a good path, and I think the support from the hardware side will keep growing, especially if we now see that the big chip manufacturers jump on the train, and this will also be a boost, I think, for the technology. And if we stay here in 3 years from now, I would say we would see more application. We have much better understood where we can apply it, or where we better should skip it, as Mark just said.
Mr. Lai?
Yeah, great technology, no silver bullet for each and every case, as said. Major issues are driving down the cost for the hardware and improving the usability for the software tools. And building up own competence.
So I think that if you are in manufacturing or in transportation logistics and you're trying to allocate your research and development budget, you need to put some budget on R&D for this, because it's definitely a technology that has survived the first adoption curve, that is going to be here for the long term, and that is going to be very, very useful.
I think like any technology, you can be too early, you can be too late, you can be at the right time. I remember neural networks being talked about in the 90s. The imputer even, I think, there was the technology that was a hardwired network. That was too early, but still there was the potential. It's just taken the time of processing, building up, knowledge building up. I think we're now getting to the point where we are really seeing adoption in some applications. So certainly it's got its future. Look at 3D a few years ago, it was very small, 3D is growing. I think we are probably a little bit behind that with deep learning, but it will get there, and it is getting there now. So now is the moment, I think.
Yeah. Thank you. Okay, are there any questions left? No, I have nothing on my tablet. So thanks to all participants, thanks to the audience, and I wish you all a great day in the Vision Fair.
Thank you.